Decomposing fractions into partial fractions, part 6, solving a, b, c, d, etc. In example 3, we are asked to evaluate the integral of x squared minus 3x minus 13 over x squared plus 4x minus 3 dx. Before we can evaluate the integral, we will first have to decompose this fraction into partial fractions. If we look at the denominator, we see that the degree is 3 and the degree of the numerator is 2. So the degree of the numerator is less than the degree of the denominator, and we are ready for decomposing into partial fractions. Furthermore, we can see that there are two distinct factors, the quadratic factor x squared plus 4 and the linear factor x minus 3, which mean we can decompose this fraction into two parts, a fraction with denominator x squared plus 4 and a fraction with denominator x minus 3. Since x squared plus 4 is quadratic, the numerator will have to be an expression of the form ax plus b, which is a first degree expression, and since x minus 3 is linear, the numerator will be a constant. We can now again multiply both sides by the LCD, x squared plus 4x minus 3. If we multiply this out and simplify, on the left-hand side, it will result in x squared minus 3x minus 13. And on the right-hand side, when I multiply my first fraction with my LCD, it will result in ax plus b times x minus 3. And if we multiply the second fraction with the LCD, it will result in c times x squared plus 4. And let's call this equation 1. Now we need to solve the values of a, b, and c. In general, we said there are two methods. One where we choose values for x, and the other method where we compare coefficients. We can also do a mixture of these two methods it will help me to make the solution easier. In this case, since we do have a linear factor, x minus 3, we can choose x equal 3 and substitute that into equation 1, and that will solve for me the value of c, which is equal to negative 1. Because we don't have any more linear factors, we can now go over to the method where we will compare the coefficients. To compare coefficients, we have to take equation 1 and multiply out the right-hand side. So that will give me ax squared plus bx minus 3ax minus 3b plus cx squared plus 4c. We will now regroup the terms on the right-hand side and take out common factors x squared and x. So that will leave me with a plus cx squared plus b minus 3ax, and then lastly negative 3b plus 4c as a constant. If we now compare the coefficients of the x squared, the x and the constant terms, it will give us three equations, namely a plus c is equal to 1, b minus 3a is equal to negative 3, and negative 3b plus 4c is equal to negative 13. If we have to solve these three equations simultaneously, we are stuck with the difficulty again of solving three equations with three unknowns. However, since we already let x equal 3, we found that the value of c is equal to negative 1, and this will make our task a lot easier, because if we substitute c equals negative 1 into the first equation, it will give us that a is equal to 2, and if we substitute that into the last equation, it will give us that b is equal to 3. We can now decompose the fraction x squared minus 3x minus 13 over x squared plus 4x minus 3 into the two fractions 2x plus 3 over x squared plus 4 plus negative 1 over x minus 3. And now we are ready to evaluate the integral. So the integral of x squared minus 3x minus 13 over x squared plus 4x minus 3 dx is equal to the integral of 2x plus 3 over x squared plus 4 minus 1 over x minus 3 dx. The second fraction will be easy to integrate, as that is a ln. However, the first fraction, we sit with the problem that the derivative of x squared plus 4 is just 2x and not 2x plus 3. So in order to overcome this problem, we will simply split the numerator of the first fraction to give us the two fractions 2x over x squared plus 4 plus 3 over x squared plus 4, and then the last fraction there, minus 1 over x minus 3. Now our first fraction and our last fractions are lns. However, the middle term is not a ln. We know that this one will factorize or integrate as a arctan, and if you know the shortcut, you will know that this will give you 3 times and then a half arctan x over 2. However, if you do not know the shortcut, you can still evaluate that integral, and we will do so in the long way in a moment. So 2x over x squared plus 4 can integrate to the ln of x squared plus 4. Now 3 is a constant, so we can take that out of the integral. And then if we look at the denominator of my fraction, I would like where the 4 is to have a 1. And I can only do that if I take out 4 as a common factor. Now to take 4 out as a common factor, it will leave me with a quarter x squared plus 1 dx. And then integrating the last term will give me the ln of absolute x minus 3. So if we now look at the the integral in the middle term, we can see that the 4 is also a constant. We can take that out, and a quarter x squared can be rewritten as x over 2 squared plus 1 dx. Now, if this integral is an arctan of x over 2, the derivative of x over 2 is a half, and that means I will have to fix the half and the 2 in order for our integrand to be the derivative of an arctan. We can now simplify the coefficients to give us 3 over 2. And if we now integrate the half over x over 2 squared plus 1, it will give me an arctan of x over 2. And lastly, we still have our ln absolute x minus 3 plus c.